Hello and welcome to Unit 9, Part 1. My name is Mr. Bell, and today we're going to talk about lines of best fit, and we're going to write those equations or look at those lines when given a graph. In this first example, it says which equation is the closest to the line of best fit. So what a line of best fit is data, more often than not, is not perfectly linear, meaning you're going to have some data points that are spread out. Maybe they don't form an exact, perfectly straight line, but we can still sort of identify a trend. And by doing that, or by looking at that, we're going to identify the best fit of a line. What line would best fit this data? And I'm going to try to draw it for you here in blue as best that I can. So if I were to draw a line of best fit, the line should go right through the middle of the data points. It represents the set of data as good as it possibly can. This red would be an example of not an appropriate line of best fit because it doesn't match the data. Even if it goes through some of the data, but still not in a good direction matching the data points, then it would not be classified as a line of best fit. The one in blue is a good line of best fit. So let's try to use that information and what we know about the equation of a line when it's graphed and see which of these answer choices is closest to the line of best fit. Well, it looks like this one has a y-intercept of about -2. So if I look down at my answer choices for the y-intercept, I'm looking for one with a -2. I can cross out the +2 and I can cross out the +2 for choice D. That leaves me with B and C as possibilities. You may also notice that the trend of this particular line is going up. As x increases, y increases. So it has a positive slope, okay? So which of my answer choices left has a positive slope? Well, that would be answer choice C, because the slope is an understood +1, implying that my line should be going up 1 over 1, up 1 over 1, up 1 over 1. And even though it's not perfect the entire way, that's a pretty good representation of this data set. Let's take a look at one more example. Here we're given some data. We're asked to find the line of best fit. And if I were to draw one as good as I can with my blue marker here, it looks to be a pretty good horizontal line that's going through the middle of the data points. Okay, that's not perfect, but that's a pretty good representation of the line in the data. So let's see which of these equations closest matches that one. Now, you may recall that y equals lines, like if it was y equals a number, like 2, it's going to go through the y value of 2, and it's going to be a horizontal line. If it was an x equals function, like x equals 5, it would definitely go through the x value of 5, but it would be a vertical line. So since we're dealing with a horizontal line, we know it's going to be a y equals function. I can eliminate the x is 5 because my graph doesn't even touch the x value of 5. I can eliminate the x value of -5 because my line doesn't even touch that particular spot. Now we got to decide, is this y equals 5 or y equals -5? And since I'm up on the coordinate plane, I know that the equation of the line of best fit for this data is the +5. Y equals +5. All right, thanks for watching. Hope this helps.